Hey guys, so I'm gonna make a video on lines and linear functions, which corresponds with 8.4 in your textbook. And so we're gonna start out with slope. While you're watching this, if I go too fast, pause the video, slow it down. If you already know the material, you can put it on 1.5 speed, whatever is gonna work best for you. Okay, first thing we're going to talk about in this section is slope. So if you have a line that has a positive slope, it's going to be increasing from left to right. So you'll have a line that looks something like that. So we're always going to be reading our graph from left to right to determine if it's positive, negative, or etc. Negative slope is going to go the opposite direction, it's going to go down from left to right. A slope of 0 is if you have like the floor that you're walking on. The floor has it's a slope of 0. So horizontal lines have a slope of 0. And then if the slope of the line is vertical, that is considered an undefined slope. So I like to just to help this stick in your brain. If you think about if you're walking across the floor, it's real easy. The slope is 0. But if you're trying to walk straight up a wall, like a vertical line would be, it's impossible. So that can help you remember that, like, oh yeah, if it's vertical, the slope is undefined. Okay, so to find the slope between 2 points, we have a formula. It's basically graphically it's the change in y divided by the change in x. So another way to say that is rise over run. You may have heard that before. But to find that change in y, like if we have a point here, let's say this is, we'll call this point right here x1, y1. And the x1 and y1 mean that I'm talking about the first point, and then x2, y2 is the second point. To find the change in the y value, well, we want to find how much it's gone up from this y coordinate to this y coordinate. So if I take y2, which is this whole distance, and I subtract this piece, I'm going to be left with what I want, which is this change in y right here. So the change in y is written y2 minus y1, and then the change in x similarly is how far have you moved in the x direction, and to find that you can take x2 minus x1. So you have to make sure that this goes in the same order. Like if you start with the second y coordinate and subtract the first, then you got to take the second x coordinate and subtract the first. If you write it the other way, it will work. So y1 minus y2, and then it would just have to be x1 minus x2. And these are called subscripts. And it's just, again, it's indicating that we're talking about a first point and a second point in the xy coordinates for each of those. So an example of this would be if you have these points, oh sorry, my screen is not cooperating. I have 2, -3, and 5, 7. If you want to pause the video and try to do this on your own, great, and come back and check your answer. But if you're not sure, we can call this first point x1, y1 because it comes first. Doesn't matter. You could call it x2, y2 if you want to. I'm going to call this one the second point, x2, y2, and then I'm going to plug it into this formula. So my y2 is 7 minus y1, which is this -3. And then I'm going to move to the x's, and since I started with this y coordinate, I have to start with this x coordinate. I'm going to go 5 minus 2. And then I'm going to simplify that. So minus a negative becomes plus. So 7 plus 3 is 10 over 5 minus 2, which is 3. So the slope between those 2 points is 10/3, or 3 1/3. What it means is every time if you move over 1 in the x direction, the y values are going up 3 1/3 units. Another way to think of it is if you went up 10 units, you would go over 3 units in the x direction. The second concept in this lesson is slope and average rate of change. So average rate of change is another way to find the slope. So let's say that you have a scenario like this where you have somebody's the time in years on the x-axis, and the height of this person could be a dog, could be a baby, whatever. Let's say that you start out at time 0, you're born, and you are 11 inches tall. So you have 0, 11. Times 0, you start out at 11 inches. After 1 year, you're now 22 inches. So we have this point 1, 22. 2 years, you're 26 inches. After 3 years, you're at 38 inches. So if we wanted to find the average rate of change or the average rate of growth over that 3-year time period, what we want to do is we're just going to ignore all the points in between, but we know that at time 0, we started at 0, 11. At time 0, we were 11 inches tall, and then at time 3 years go by, actually this is very short if this is an actual human, but that's okay. 3 years go by and now you're 38 inches. So to find your average rate of growth over that time period, if you take this, if we call this one x1, y1, and this second point x2, y2, and we use that slope formula, we're going to have 38 minus 11, which is going to tell us how many inches we grew in that time period, and then over 3 minus 0, which is how many years have gone by. So 38 minus 11 is, what is that, 27. You grew 27 inches over 3 years, which means 27 divided by 3 is 9. And the units that go with that is, this was the change in inches over the time. So my units that are going to go with this average rate of growth are going to be, pay attention to the units that go with the ordered pairs, it's inches per year, which we can write like this. So on average, this person, whatever object it is growing at a rate of 9 inches per year. But if you look at this, that's not how fast they're growing every single year. From year 0 to year 1, there's an 11-inch difference, which is greater than that average. But then it slows down and then picks up again a little bit. So on average, though, 9 inches per year. But every year, you're not going to grow the same amount. It's going to depend on a whole bunch of factors, in fact. But that's how you find an average rate of growth. The third concept in this lesson is the slope-intercept form of an equation of a line, which is, hopefully you've heard of this before, but it's this y equals mx plus b. X and y are going to be points on the line. There's an infinite number of, if you draw a line, you're going to have an infinite number of points on that line. Remember from geometry, a point is infinitesimally, it's too small to actually graph. We pretend that we can graph points. Like I put this big blue dot there to indicate a point at the beginning, but it's just to represent where that point is, but it's actually incredibly small. So you have an infinite number of points on any line. But this number that's in front of the x value, or the x variable, it's called a coefficient, and it represents the slope of the line. So the slope is just the number in front of x, not including the x variable. And then the number back here, the b, so m and b are going to be actually numbers. X and y will stay variables. But b is the y-intercept. So if you think about a line, all lines look the same. They're all just straight, but the difference between any line and another line is where it's located and its slope. The y-intercept tells us where it's located. The slope tells us how steep that line is. So an example of how you might want to use this is, let's say you need to find the equation of a line with a slope equal to negative, or to positive 1/4, and a y-intercept of -2, and then we're going to graph it. So if the slope is 1/4, that's m in this equation, and the b value is this -2. So if I just put that, if I replace the m and the b with their values, I get y equals 1/4 x minus 2. You can put plus a -2, but you can also just write -2. Graphing that, your y-intercept is -2, and what that means is you cross the y-axis at -2, And then if I have a slope of 1/4, remember slope is rise over run, so we're gonna go up 1 and over 4 units to get to the next point. And you can keep doing that. 1, 2, 3. I ran out of points here, and I can also go, if I go down 1 and to the left, that's a negative over a negative, which is a positive. So you can, sometimes you have to do that because your graph paper doesn't fit if you're trying to go up and over. So you can always remember to go down and to the left if that works better for you. All right, so that's slope-intercept form of an equation of a line. So here in this next part, we're going to find slopes and y-intercepts. So if it's in the slope-intercept form of a line, and then we're going to graph it, it's pretty straightforward. Find what's in front of the m and what's in front of the x, and that's your slope, and the constant. But these two problems, A and B here, are not in slope-intercept form because y is not on one side by itself. So what we're going to do is we're going to put them in slope-intercept form. So if I have 2x minus 3y equals 6, what I want to do, if I'm trying to get it in this form, I want y on one side by itself. So I'm going to try to get this by itself, and I'm going to try to get that negative 3y on that side by itself first. So I'm going to get rid of this 2x. I'm going to subtract 2x from both sides. This is gone because 2x minus 2x is 0, and I still have a negative. Don't leave that negative off. Negative 3y. And then I'm going to put, instead of 6 minus 2x, I'm going to put negative 2x plus 6 because I know I want it to be in the form mx plus b. So I'm putting the x term first. And the x, notice that negative 2x, that negative is attached to that 2x. The 6 is positive because there's nothing in front of it. And then I still need to solve for y. So I have negative 3 times y. So think of the inverse operation of multiplying, which is dividing. And when you divide, every term needs to be divided by that negative 3. So negative 3 over negative 3 is 1. So you have 1y. I'm going to move over here. And then negative 2 over negative 3 is positive because it's a negative divided by a negative. So I have 2/3 x. And then 6 divided by negative 3 is negative 2. Sometimes you might come out with a y-intercept that's not a whole number, so you're going to have to just estimate where that is. But negative 2, the y-intercept is negative 2. This is your slope. And the negative 2 is your y-intercept. So that means, again, where it crosses the y-axis is at negative 2, and then I have a slope of 2/3. So I'm going to go up 2 and over 3. So here's a second point. You could keep going with that, but I'm just going to do a quick example there. And then why don't you pause the video and try to rewrite B in slope-intercept form and graph it, and then come back and check your work. Okay, so I got y equals negative 2x plus 4. So what I did is I subtracted 4x back up here, and then I had 2y left, and so I had to divide by 2 because it's 2 times y. Undo that by dividing, and remember to divide every term. When you divide or multiply, you got to do it to every term. And so negative 4 divided by 2 was negative 2x, and then 8 divided by 2 was 4. So then the y-intercept is up here at 4, and the slope, remember, is rise over run. If the slope is negative 2, you can make that into a fraction by putting it over 1. So you're going to go down 2 from that point and over 1. Down 2, over 1, and you get your line. Okay, so that is part 1 of 8.4, and I will come back and do the rest. Parts 5 and, what does it go through, 6? Let's see. Actually, we have 7 pieces to 8.4. So I'll make another video on 8.4, and I'll put that in to Canvas tomorrow, and then I'll work on 8.5 and 8.6. All right, have a good night.